And welcome back, everyone, to Beyond the Forecast. I am Chief Meteorologist Michael Stevens. Happy Monday, and I hope everyone had a wonderful and safe 4th of July weekend, holiday weekend. Now we're back to work life. Kids, hope you're enjoying summer vacation. But today we are going to talk about two things that are tied in heavily to a lot of the weather that we saw this past weekend, not only here in Michigan, but also across the United States. Now, meteorologist John Gross, first up, is going to take you into weather versus climate. It is very important that you distinguish the difference between what is weather and what is climate. And that will definitely set you on the right path to understanding the difference between what is happening now and what has happened over the long run. And then he will take us into air masses and why these play a pivotal role in the weather across the United States. Air masses give these areas that see weather, like us, like the South, like the West, like the East, those air masses dictate just what the weather will do on a daily basis. And meteorologist John Gross will have that. And then if we have time at the end, we'll tell you a little bit about the Beyond the Forecast live streaming podcast. This day in weather history, July 7th, 1950, a severe wind and thunderstorm caused heavy damage and 38 deaths near and in Cincinnati, Ohio. Many older buildings were demolished and the steamship Dick Fulton was overturned. Yeah, that's insane. A severe wind and thunderstorm toppled a lot of buildings in and around Cincinnati, caused 38 deaths, and overturned a steamship back on this day in 1915. That's a pretty wild this day in weather history. All right, trivia time. Yesterday, we wanted to know, what does the Saffir-Simpson scale measure? Is it snowmelt, sunray power, hurricane-sustained winds, or darkness? Yeah, it's hurricane-sustained winds. That's the Saffir-Simpson scale. But for a lot of us, we hear about the categorized scale of hurricanes. The Saffir-Simpson is basically how you get to a category 1 through 5 hurricane. Today, we want to know, what is the common name for a tropical cyclone in the Northwest Pacific? I've told you this many, many times. Let's see if you've been paying attention. Is it a tornado, a typhoon, a hurricane, or a cyclone? QR code right there. Hit it with your phone. That'll take you where you can answer, and we will have the answer for you coming up tomorrow on Beyond the Forecast. All right, weather word of the day. I have never heard of this one, and you will be very shocked when you see the consonants in this word. It is Syzygy. Syzygy. Yes, and it is spelled S-Y-Z-Y-G-Y, Syzygy. This refers to the 2 times a month that the sun and moon are aligned, which results in us either having a new moon or a full moon. Syzygy. Never heard of this. Never. Syzygy. There you go. Weather word of the day. It's when the moon and sun are aligned. Wild one for you today. Viewer photo of the day, brought to you as always by Great Rooms. Today's picture comes to us from Janice Bjorkquist of up towards Curtis. She brought us the phenomenal sunset on Big Manistee Lake. Look at this absolutely gorgeous photo. Thank you so much, Janice, for sending this in. Absolutely stunning photo, and thank you to Great Rooms, as always, for sponsoring Viewer Photo of the Day. All right, let's send it over to meteorologist John Gross, who's going to break down the difference between weather versus climate. And then on the other side of that, he is going to tell us the difference between air masses and regions and why it dictates the weather they see. We'll have all that coming up right after the break.
Hey there, everybody. Meteorologist John Gross, and today we're going to be talking about what exactly is the difference between weather and climate. These are two definitions that can get mixed up all the time, so we're going to focus on the definition. We're also going to focus on different types of examples, and one main thing we'll also touch on right at the beginning is going to be whether you're talking about weather, whether you're talking about climate. One thing that drives them both is the data that we collect for both. A weather forecast, a climate outlook is only going to be as good as the data that we collect to put in our weather forecasting models, to put in our climate outlooks. That is key, and that is number one in how we start any weather forecast or any climate outlook. Here's a look at weather. Here's the definition. You're talking about a specific forecast that changes day to day. So this is something that we would air on our programming every single day. Today's forecast, tonight's forecast, tomorrow's forecast, Friday's forecast, the weekend forecast, ways we can describe that. You're talking about today, we're looking at sunny conditions. Tomorrow, we're looking at windy conditions. Tonight, we're talking about rainy and snowy conditions. Friday, we're talking about stormy conditions. This weekend, we're talking about sunny and windy conditions. So that's the main way we talk about weather, and that one, well, it's a little bit more self-explanatory. Let's dive into the climate side of things. This topic, it can be a little bit touchy. We'll just put it out there, but when you're talking about different types of climate, you have to look at first of where you're located on Earth, because Earth has different types of climates. You could be well north, near the North Pole, areas into the tundra. You could be talking about very cold conditions. You could be talking about very snowy conditions. As you're going farther south, areas near the equator, you could be talking about very warm conditions. You could be talking about more so in the way of tropical conditions. You have a lot of moisture to work with. Or, in this graphic behind me, you could be talking about areas in the desert that don't see a lot of rainfall. Very hot conditions, drought conditions. Those are ways to look at climate. So you're talking still about weather, but it's average weather conditions that we observe over a long period of time. Now, usually when you're talking about the 30-plus years, you're talking about averages. You're talking about records. You also can look at climatological things on a monthly basis, or even a few weeks out from where we currently reside. So you can look at temperature outlooks. You can look at precipitation outlooks from the Climate Prediction Center. Other things that you can look at how patterns in the Pacific Ocean are going to be setting up, potentially for the winter season. This is a huge topic we talk about. Either we're talking about an El Nino versus a La Nina pattern. Do we have warmer than average temperatures near the equator in the Pacific Ocean? Do we have colder than average temperatures near the equator in the Pacific Ocean? So those are main things that we talk about when you're describing climate. So here's an example. When you're talking about climate, let's go ahead and just focus on Michigan in the wintertime. And if you're trying to describe how the climate is as a whole in the state of Michigan during the winter season, you would say there typically is a lot of snow in the winter in the state of Michigan during the winter season. If you were looking more at the weather side of things, you would say Friday's forecast, tomorrow's forecast, we're expecting a half a foot of snow. So those are the differences between weather and climate. Now, I lead by example, or at least I learn by example, so I think this will be a little bit more helpful to kind of drive home some of those topics. Here's a look at weather. You're talking about the example for tonight. I grabbed this from yesterday's forecast. We were talking about temperatures specifically. Low 20s to the low 30s, partly cloudy skies. Lake effect snow was starting to end. You were talking about windy or at least breezy conditions, northwest winds, 10 to 15 miles per hour, but gusts at times still could be near 35. A very specific forecast for a very specific time frame for tonight. Let's focus on another one. Here's a look at tomorrow. You're looking at a snapshot of when we show you our zone forecasts. Areas near the tip of the mitt, going into eastern upper. You're talking about upper 30s, low 40s, so we call that mild temperatures. So it's mild. You're talking about decreasing clouds. So we're transitioning more towards sunny, light conditions as we're getting into the day tomorrow. Winds from the northwest, 15 miles per hour, but gusts near 25. So windy conditions, sunny conditions, mild conditions. That's specifically the forecast as we get into the day tomorrow. So that's some weather examples. Here's a look at some climate examples, and this is taking a look at some data coming in from the Climate Prediction Center. I also pulled this from their website just the other day. So you're looking at precipitation, you're looking at temperature outlooks, 8 to 14 days out. But notice you're not given any specific numbers for temperature. You're not given any specific numbers for moisture. You're given above average, below average, near normal. So this is depicting that areas from the Great Lakes going into the southeast as we're getting into the first week of May, or at least close to it, rounding out April. we're going to be trending a little bit warmer. Areas throughout the plains, even going towards the Great Lakes, ending April, approaching May. We're expecting wetter than average conditions, but that's that collection of data that we have gotten over the decades. And this is how we can draw these different types of temperature outlooks or even precipitation outlooks. Now, another thing we can focus on is drought. So now you're talking about the seasonal drought outlook. So I pulled this from the Climate Prediction Center as well. You're talking about this being valid right here from the beginning of April going all the way out to the beginning of July. So depending on areas that are more susceptible to drought, are you talking about higher than average rainfall amounts? Are you seeing lower than average rainfall amounts? And we can depict based off of data over the decades if we're expecting drought to worsen, if we're expecting drought to improve, if we are expecting drought to get better. So that's another way that we can describe the climate. Here's one last example, and I think this one will drive home a little bit more because this one is focusing a little bit more on averages as well as records. And this is really where the longevity of collecting data comes into play. So this is an outlook, or at least the temperature climate report and the precipitation report from Traverse City. And this is taking a look again at the climate summary. So here's the look at those records. Climate reports. We go all the way back to 1991, but our climate record period, that goes back to the 1800s. So here's a look at your observed values, 47 and 35, but record values, 88 and 6 degrees. So you got to go all the way back to 2002 and 1904 to see when we had our coldest and our warmest day in Traverse City on this date, back in April 16th. So again, we're looking at data over the decades or even over a century, but it's that collection of data for a specific area over a very long period of time that gives us these records, that gives us these averages, that tells us, are we where we should be for this time of year? And as we continue to see that data and where it goes over the years, over the decades, that's how we can see, is the climate changing? Is it staying the same? What can we expect going into next year, going 10 years down the road, things of that nature. So that is the difference between weather and climate. I'm meteorologist John Gross reporting for Beyond the Forecast.
Thanks, John. Now coming up, John will be back with us to talk about air masses and why they dictate the weather you see on a daily basis. We'll have that right after the break.
Hey there, everybody. Meteorologist John Gross, and today we're going to be talking all about different types of air masses and where exactly do they originate from, because depending on where you're located on planet Earth, you usually will encounter different types of air masses depending on what type of climate you're usually more accustomed to, depending on your location on Earth. So there are two main types. You have your maritime air masses, which are usually found over a body of water, and then you have your continental air masses, which are usually found over any type of landmass. So let's go ahead and talk about the different ones, and whether you're talking about a warm and tropical air mass, whether you're talking about a drier air mass, or whether you're talking about a very cold air mass. Again, just depending on where you're located, and that's what helps to tie into the climatological side of things. So there are 5 main ones we'll touch on. Here's a look at the first one. You're talking about maritime tropical air mass. Now, usually with the word tropical, you're talking about some warmer conditions, hence warmer bodies of water, because you're talking about the word maritime. So here's a look at where some of those do originate from. You're talking about areas from the Gulf. You're talking about areas from the southern Atlantic Ocean, the Caribbean Sea, even the southern Pacific Ocean. These are some spots that we're usually talking about, again, that warmer air mass over the water. And especially for us in the United States, this is a very key thing to watch when we're getting into hurricane season, because that's one of the main drivers that you need for a hurricane to not only develop, but to stay strong. You need very warm sea surface temperatures. So that's one main thing that we're talking about with the maritime tropical air mass, again, over bodies of warmer water. Now let's go ahead and focus on the continental tropical air mass. So again, continental, you're talking about over a land mass, and at least the continental tropical, especially areas throughout northern America, a little bit more susceptible to areas going throughout Mexico, or at least northern Mexico. One of the main examples that we do talk about during the summertime is the North American monsoon season. So when you hear the word monsoon, you think of a very moist air mass. So that's usually what you're talking about, a lot of warmth and a lot of moisture. Again, originating from a continental tropical air mass, originating over a certain type of landmass. So that's looking more at the tropical side of things. Again, those warmer air masses over bodies of water and even several different types of land masses. Let's go ahead and focus on some colder air masses. So now we're talking about the maritime polar. So remember the word maritime, that's over a body of water, and then polar, you might have heard of the polar vortex, to say a few words. That's kind of looking at, again, usually colder temperatures. So here's a look at where some of our maritime polar air masses originate from. So typically, you're talking about colder, again, colder bodies of water, polar, using that word. Some of those main originating areas, you could be looking at the northern Atlantic Ocean, you could be looking at the northern Pacific Ocean, you could even be looking at the Gulf of Alaska, but all three of those have one main word in common: northern. So as you're going farther north in latitude, remember temperatures, at least on a climatological standpoint, those are getting a little bit colder. So that's why you're talking about some of those colder air masses. And usually, again, you're talking about the Northeast going towards the Great Lakes and even the Pacific Northwest, where you have a little bit of a better chance to talk about chances, especially as you're getting into the winter months, not only for some rain, but even frozen precipitation, and that also could help to lead into chances for some snow. So that's the maritime polar. Let's go ahead and talk about the continental polar. So here you are talking about a landmass, usually as you're going a little bit farther north, and the main one, at least into North America, as you're going north of the United States, is Canada. So that's going to be one of the main spots you're talking about, continental polar air masses. So where do they originate from? These are typically oriented from colder and dry areas of land. So you're not always talking about snow-covered areas. It can be a drier area of land, but still much colder in temperatures. So like we were mentioning, areas from Alaska, the Yukon, Northwest Territories, and even still as you're going farther north into Canada, even into the Canadian Rockies. That's where you can talk about some of that colder air moving down from Canada, especially into the northern tier of the United States, and that can also help to really help cool us down during a period of time. If you're talking about colder air masses moving in from the north, that is going to result in some much colder temperatures, especially areas as you're going farther throughout the northern tier of the United States. Last but not least, let's go ahead and talk about the continental Arctic air mass. So you have heard of polar, so you're thinking cold, but now when you're talking Arctic, that's even colder than your polar air mass. So continental, so you're over body, or I should say areas of land. So now you're starting to get into areas even farther north, closer to the Arctic Circle. And remember, as you're going farther north in latitude, temperatures just climatologically, they start to get colder. So now you're even talking about a colder air mass moving in. So this is typically originating from very cold areas, such as areas closer to the Arctic Circle regions where there is snow, where there is ice. So that allows the temperatures with these air masses to even be colder. If we're talking about, you might hear us say sometimes, we have a big Arctic blast on the way, especially going into the winter months. That's usually referencing a continental Arctic air mass moving well from the north, areas farther south, and that's also a time where we could talk about temperatures. Again, especially more towards the winter months. We'll go ahead and reference us here in Michigan when you can get temperatures, wind chills near zero, well below zero, negative double digits, things of that nature. That's when you're really starting to talk about those bitter cold temperatures when you're talking about continental Arctic air masses. So that's all the differences. Remember, you have maritime, you have continental. Maritime is over a body of water. Continental, you're over a landmass. And then you have tropical, polar, and Arctic. Tropical, you're talking about that warmer air mass. Polar, you're still cold, not technically needing snow or ice, but when you start to talk about the Arctic air mass, that's when you really start to get those really cold temperatures. I'm meteorologist John Gross reporting for Beyond the Forecast.
We do truly appreciate you being here again. Thank you to meteorologist John Gross, meteorologist Haley Fischetti, and myself, Chief Meteorologist Michael Stevens. Be good, stay safe, take care. We'll see you guys all right back here tomorrow, Tuesday, 4:30, for more Beyond the Forecast. Bye, everybody.